Hello everyone. In this video we are going to start coding the a priori algorithm in Python. So I'm going to assume that the data comes in a text file like this one, for example, right, where we basically list all the items or products where separated by comma, and each row corresponds to one transaction. Also, it doesn't matter what the names are. So here it could be like apple, onion, or milk. It doesn't matter, right? Because the algorithm will parse them as strings, okay? So recall that each row is going to be one transaction and the items are separated by comma. Okay, so the first thing we have to do is to define a function that loads the transactions from the file. So we can do the following. So I'm gonna call it load transactions, right? It's going to receive the path where the data is, right? And also is going to receive the order, because remember that the algorithm needs the lexical order, and we are going to sort the list of items on each transaction according to that order, right? So let's use a list where we're going to be appending the transactions, and now we have to open the file. So it's going to be path to data. We're going to read it, right, as FID, and then so we're going to loop over each line in the file, right? First I'm going to create a list from the line of strings, right? Such that the line, we are going to strip it. Basically it takes away all the characters that are not a product name, right? And then we are going to split by using the comma separation, right? So with that we have one list of items, okay? Now we need to get rid of any repetition of items within one row, because at least in the version we are implementing, the vanilla version of the a priori algorithm, we will not take into account the amount of times one item occurs inside one transaction. So for example, if there is one transaction that has 3 boxes of milk, we are just going to consider it as milk, okay? We're not using the number of repetitions. So we can do that by using we can use the numpy function unique of the previous list, okay? So with the unique we are going to remove the repetitions. So we need to import numpy as np. Okay, so now we need to sort this transaction according to the lexical order. Okay, so this is going to be done by using the sort function of list. So we can pass like a key here through a lambda function that is going to apply the order based in the index of it. For example, why? Because if let's say that the order comes in a list like this, right? I1 for example, let's say there is just 4. We basically what we are doing is like the order the important thing inside the order list is the index, right? Because at the end, if one item is greater than other inside this list, is gonna depend just on the index or of the position of the item within this list. So this is why we use the order as the lambda function, right? So okay, after this we can append this transaction into the transaction list, and finally we return the transactions. So now let's use this function to load the transactions and see if it's working. So I'm gonna import numpy as np here, and also I'm gonna import from utils this file, right? The one where I wrote the function. I'm gonna import everything for now. I know I'm just gonna write there a few functions. So in general, we shouldn't import everything from files that we don't really know how many functions are there, but for these purposes it's fine. So let's say that now we're going to load the data. Okay, so I'm gonna do here that, and then okay, so we need to define the path to data, right? Which is where the our data is. In my case, I have it in one folder called data, and then one and data1.txt. Also, remember we need to define an order, right? So in this case, given that we know that the items are I1, I2 till I5, so we can do something like this. So the order must be a list, right? And I'm gonna do this way. 1 to 5. So in this case, this is going to create the order as a list of I1, I2, I3. So let me, for example, print order here. We can see that that's the order, right? Okay, so now let's use the function. So the transactions are going to be equal to load transactions, and we're gonna pass the path to data and also the order. Okay, so let's see the transactions, and here we go, right? Okay, so now, for example, let's say now we're going to do the initialization. And we will start with C1. So we are going to represent C, the set of candidates, as a dictionary, right? Same thing for L, where the keys are going to be the iteration. And so we want to do the iterations over the size of the item sets, right? So C can start as let's say like item set size will start with 1. Okay, and then the first thing is that the C is going to be initialized with the item set size equals to 1, right? And then here we're gonna put all the candidates of item sets of size 1. So in this case we can do this way. For F in order. Okay, now we need to create L1, basically the initialization of L, and this is basically a dictionary very similar to C, but only containing the frequent item sets. Also, we're going to have to keep track of the frequency of each of the item sets we are saving in L. So for this, we're gonna need a helper function. So first, let's say like we are going to use one variable called support count for L, which is going to be a dictionary, and the function is going to be called getFrequent, and it's basically going to receive C of the corresponding iteration. So in this case, it's going to be one specific component of C, right? It's going to need all the transactions to check the frequency of the candidates. It's going to need the minimum support, right? And also is going to need all the previously discarded item sets, okay? Because to avoid, right, counting for item sets that contain any subset that was previously discarded, right? This function is going to return three things. Basically, first, the set of frequent item sets, okay, we can call them F, then the support of them, and then the new discarded item sets that are going to be used in the next iteration. We are going to implement our helper function in the same file utils.py, right? So the name was getFrequent. Where's frequent? So this is going to receive a set of item sets. So it doesn't matter what iteration, right? It's always going to operate the same way, receiving a set of item sets and then checking their frequency. Then the transactions, the minimum support, and the previously discarded item sets. Okay, so we can initialize L as a list that is going to have the frequent item sets. This variable, the support count, is going to be also a list. It's going to give the counts of the item sets. Here we're gonna save the new discarded item sets that are going to be the item sets that we discard in this iteration. And we can keep in one variable the number of transactions because it's going to be used to calculate the frequency. So in order to not compute the length of the transaction more than once, we can keep it in a variable. Also, we are going to use one variable called k that is going to keep the length of their previously discarded sets of item sets, right? And we are going to go over the item sets. So here we need to do two things. I mean, the first thing is to, at the end, is to calculate the frequency of every item set to check if they are frequent or not. But before going and counting their frequency, we just need to check if the item set contains any subset that was previously discarded. Okay. For that, we are going to use one flag variable called that will tell us if the item set contains any subset that was previously discarded. Okay. And now, in case the size of the previously discarded item sets greater than 0, it means that actually we have item sets that were discarded in the previous iteration, right? So if now we are going to check for each of the previously discarded item sets if they are subsets of the current item set S. So here we are checking the last set of item sets that were previously discarded, right? So we basically will use Python sets, right? So we are going to check if the previously discarded item set is a subset of the current item set S. So in that case, we're gonna set the flag to true, and we are going to break the loop, right? Because we don't need to count the 8th frequency. And I mean, recall that we are here breaking the loop of this part. Basically, we don't need to check for all the other previously discarded sets, right? So in case the item set does not contain any previously discarded subset, that means that the flag is false. So if the item set S does not contain any subset that was previously discarded, means that we have to count the frequency, right? For this, we are going to use a helper function that will take care of this, right? So it's going to receive the item set in particular and all the transactions, and is basically going to return the frequency or the count. And we are going to check if the number of occurrences divided by the total of transaction surpasses, is greater or equal than the threshold, then it means that it's frequent. So we are going to append it to L, and also its support count. And in case it doesn't surpass the threshold, we basically are going to save this in the new discarded item sets. And that's it. So we will return L, the support count, and the new discarded item set. So actually here I'm seeing that we are not using this variable more than once, so we can just cut it, delete this variable, and use the len. It's a bit cleaner.